All right, as of now, you all should at least, if you're not finished, at least know how to go through and answer the majority of these questions. This was an actual AP free response question that was given not as a multiple choice question. Looking at what's there, one of the first things that I'm going to ask us to start doing, so you all have a really good idea of what's going on, label when you're given a graph. Like, I mean any graph. It could give you a graph of acceleration, position, the function, the derivative. Label what it is before you even answer the questions. Because I really think that some of us struggle with it because you're not quite sure what is getting mapped out. This right now does not show you position at all. This only shows velocity. And velocity is a combination of speed and direction. Make sure that we're aware of that. So that's why I made sure to write next to that graph that it in fact showed out the velocity. Now, so looking at what's there, first thing up is, at what time does this squirrel change direction and justify what the answer is going to be? So let's look at what's there. And Josh, what would you say?
It's the t equals 9, t equals 15.
Why?
Because on the graph B, on the interval, 0 less than t less than 18, t changes from positive to negative at t equals 9 and negative to positive at t equals 15.
You're close. He said t changes. What's that? Velocity changes, okay? Now, I'll say this. I actually don't like, in hindsight, although I'll let it slide, because the t, you're saying you would not, I don't even think at any points for that, just so you know, too. The time itself changes everywhere, right? So you've got to make sure. Now, I don't know if this would be sufficient. And I would go through and say, this might be even a better answer than what I have. If instead of velocity, it references v. So I might just say v changes signs. Your justification and everything was correct, but you need to make sure that you're saying what's changing and why. We have questions on that. Okay. Next one up. At what time is it furthest from the building? And, how far is the squirrel from building A? At what time in the interval is the squirrel furthest from the building? So we need to figure out when it's furthest away and how far from building A is the squirrel at that time. The velocity tells you the distance and the direction that this squirrel is running. Where is it? Is it running towards the building or away from the building from 0 to 9? Which one? What'd you say? Away. It's running away from the building because that distance between them is increasing. What's happening from 9 to 15? What's happening from 9 to 15? It's going towards the building, and then it ends going away from the building. How can we figure out how far away from the building it is at 9 seconds? Hands up, please, when you can tell me. This shows me you've got a good read on what's going on. Jason, how can you figure out how far the squirrel is from building A at 9 seconds? You're absolutely right. What shape is that? How do you find the area of a trapezoid? Perfect. You said it absolutely correctly. What is the area underneath there in that first region? Hannah, too, what do you say? What'd you say? All right, so let's label this as 140. So that's what that distance there is. Abby, what's the distance that this squirrel has gone back in this second region? 120. All right, and what's the distance that it went away, Sierra, in the third region? Now, I got one problem with something that's there, though. I got one problem with something that's there. And what'd you say this one was? I'm sorry. 25. This one, I got a different value. Did anybody else get a different value for this middle wedge?
Negative 50.
50? Yeah, this would be 50 or negative 50. It all depends on how you want to interpret it. Okay? But 1/2 AB times the height. Now, looking at what's there, let's answer these questions. So from 0 to 9, the distance that they are away is 140. Here's the algebra as to why the values are. So, at what time is it furthest away from the building? Who can tell me at what time? Keep a tally going. When is this furthest away? We got 1, 2 of us? 3?
T equals 9 seconds.
What's that?
T equals 9 seconds.
Yeah, T would be equal to 9 seconds because they've gone, all right, so they've gone 140, then they go back 50 and 25 more. That means they're furthest away at this point here when they are 140 away. And how far away are they? It would be 140 units. By the way, and you could add all of them up to figure out how far you are away at 18 seconds. It's not going to be more than 140 though. Questions on that one? All right, let's take a look now. That gets us to C. What's the total distance that the squirrel travels during that time? So, how far has the squirrel traveled during that time? What's the total distance going to be, Davey? What's that? 215. How'd you get it?
I added the 3 years together.
Perfect. 215 units, whatever the running is. Yeah. Yes, you would. Why would that be the case? Because there is a difference. He brought up a good question. There's a difference between displacements and distance traveled. No, what is it?
Distance traveled is without vectors.
Yeah, think of it this way. Imagine if you went and you bought a car and the guy, you go to pick it up, and it's got 5 miles on it. It's 96 Mazda 3 or something like that, right? Now it's got 3 miles on it. You go, that's fabulous, and you show up and you look at the thing in some rust bucket, and it's only 3 units. How did he measure? He would measure what? Just displacement. Maybe the distance from John Holt's to the house is 3 miles. Everything else, because if I drive to work and then I drive back, does that odometer go down? Because I'm coming back home, they go, oh, you're coming back home, we're excited. And take that mileage right away. Now, right, and you'll get this when we do it, because I'm telling you now, I'll warn you. As somebody who never took physics, the word problems for me are where we struggle. So, make sure that, and that's why I'll spend time when we talk about displacement and your explanation of vectors, you know physics better than I. So if I'm saying something that you need some clarification on, let me know. Because someone in here can help you out. Raise your hand if you've taken at least some Reach physics. That is. Anyone taking like an AP physics? Okay, right? Even better. And isn't AP physics like 3 different tests or something like that? It's like a mechanical one or something? Electrical? Physics C, whatever. All right. Now, write a piecewise expression for the squirrel's acceleration and velocity for that interval. Now, first thing up is I need to write an expression to represent what the squirrel's velocity is. When is it from? From 0 to 10. So I look at this. I need to find a piecewise function that models this range right here. Looking at what you have from here to here. That's what I model. Now, how many pieces does my piecewise function need to have? Hands up, please, when you can tell me. Seriously? What? 3. We need to represent these 3 pieces. So I go through, keeping inventory, I go, all right, so we've got this here, we've got this piece here, and we've got this one here. You tell me, how are you good? Which one of these can you go through and tell me the equation of? We've got one person. Oh, wake up. This is H1. Mike? What's one of the pieces? Do you want to give the yellow, the green, or the blue?
I'll give the 3.
Boy, you picked the tough one. What is it?
Y equals 0. Wait.
We're doing our velocity
Y
function
equals 20.
from where to where?
From 2 to 7.
You need to put those constraints on it. You need to put those constraints on it. And by the way, some of you might be arguing something right now. Does anybody see something that they're going, well, wait a minute, I might do this a little different. No one sees something that you might independently do differently and also be correct? John?
Is it switching the 20 and 2 to T to 7?
No, that wouldn't be right. Because it always goes to function and then when you're doing it. Did anybody want to include, make 20, get the closed circles there? You can if you want to. That means you're going to have to change what your other intervals are. What about the other pieces? Noah, which piece do you want to give? Do you want to give the one that is in yellow or the one that's in blue?
The ones in yellow,
Okay, what's the equation of that going to be?
y equals 10x.
There you go. How'd you get that? Careful, and by the way, he's wrong. It's not 10x, it's 10t. Who can tell me how you know that? Seriously? No clues at all. What?
So,
Yeah, it's changing, and you take the slope, y equals mx plus b. You can even put it that way. Your slope is, it tells you on there, it goes from 0, 0 to 20. Is it 220? Is that right? So if that's where it's going from, rise over right. You rise 10, rise 20, right 2, and your y-intercept would be 0. Now, when we give this one out, notice it starts, oh, wait a minute, this on mine is incorrect. Can anybody tell me what's incorrect on mine that I want to go through and omit? Yeah. To where? You're not entirely correct, that's Steve.
Oh wait, no, that's for acceleration.
Who can tell me what's incorrect, Mike?
It's supposed to be 0 is less than or greater, less than or equal to t.
What?
But I thought it's not supposed to be equal to.
Oh, it is, because you're giving out the function. Now, we got one more we've got to give. You look at that last piece. You can tell me a slope and an intercept if you extract it out far enough. You tell me what that last piece is. Don't be a baby. You're big kids. If you need to stretch the line out, figure out what's the equation of the line going to be for the second half, or sorry, for the other half of this. Figure out what the slope is, what your intercept would be. We'll wait for 7 of you. Don't wait and pray. This is 9th grade math. We got one person. 2, 3, 4, 5. We'll wait for 9. We're at 5. 5 people. 6. Thank you. 7. This is what I get paid to do, basic stuff. We don't show movies. We can't watch movies. You can't give me the equation of a line. Outraged and offended. Not here. Wonderful. We don't even choose right. Noah, what's the slope of that line? Negative 10. Steve, what's the y-intercept? Nope. If you trace that blue piece back, what is it? What? Can't hear you. 90. Yeah. If you track this back here, it would make contact at 90. Now, you could do y2 minus y1 to figure it out. You got 2 points. Doesn't matter. Now, when we list it out, though, what does our interval have to be on this? Cam? From where to where? Tell me what I'm writing out. What's behind here? It's partially right. Screwed up the first one. Now, what is wrong about me including the 10? Who can tell me why I'm so disgusted with myself personally for including the 10? What? 10 isn't included on the interval, loves. What does it say right here? Now, the second piece is write a acceleration function as well. You gave me the piecewise function. How do you get the acceleration function? Mal, what would you have to do? Let's say this. How do acceleration and velocity relate to each other?
Acceleration equals 0 to velocity.
By the way, that means you can say acceleration is the You said acceleration is the derivative of velocity, is that right? Yes. You could also say acceleration. Yeah, that would be what we go through. That's okay. You've got to make the connection. I'm trying to see if we can understand that relationship going back and forth. Because if you have the acceleration function, what do you have to do to figure out what the velocity function is going to be? Integral, the antiderivative. Yeah, that's going to get you back one way to the other. The breaking down is going through and taking the derivative. The breaking up is the antiderivative or integral. So I go through and say, and that's the first piece that I go through and say, Canon 1, what is the acceleration function then going to look like? Good. Notice I'm not including those values. Why am I not including the endpoints or the transition values?
You can't keep
Why? What do you have there?
corner.
Corners. What'd you say? The slope is different there, yeah. And that shows me you get what's going on. Questions on that? Now, you picked up a second sheet when you came in as well. This one right here. Okay. Now, what I'm going to ask you to do, and I'll say this, I'll take a second to bring this up, because I was so proud. So Miss Coy, who here has seen or had a teacher before show one of these TED Talks in class? They are, people essentially get asked, I don't even know what TED is short for, whatever. Maybe, I don't think it has anything to do with that movie TED. I think they're slightly different things. Do you think so too? Okay. It's about like, people give speeches, some of them are motivational, they talk about overcoming things, etc. One of the things though that I found fascinating was, and as you know, I have such a love for Miss Coy, like beyond words. Who here has Miss Ham? And/or has had her? Okay. If you have her, this student, this guy right here, that's giving a talk about whatever the nanotechnology, I think is making, nano means smaller, so whatever that. It's making technology smaller. And frankly, based on the size of my iPhone, I need them to stop making it smaller because my eyes aren't so good. I would love it if they'd even give me like a television to carry around as a phone. That's how big and how terrible my eyes are. Stop making things small. But in any case, this gentleman went to Webster when it was Webster High School. Went to Webster. I think he graduated even with Mr. Stragan. Got asked to give a TED Talk. Mr. Gamina reached out to me and said, I saw your TED Talk as a Webster grad. You did a fabulous job. You did great. You did really a great job. He wrote back, and by the way, could he have literally just hit trash and say, whatever? He didn't. He wrote back to Mr. Gamina and said, thank you. I had a wonderful experience at Webster High School. You know who he credited with getting himself ready to go into the real world? Miss Ham. And how could he have credited me? He's older than me. And Miss Coy. And he specifically went out of his way to credit just those two people. Now, you don't realize the assets that you have in this building. This camp is insanely smart. Insanely smart. And some people sit there at times and you don't realize how much value for your dollar you get here. She is just a genius. And those speech and debate, who does speech and debate here? Does anyone do that with her? She's like, you guys win a lot of stuff, right? Like, do you ever look at other teams and be like, this is kind of not even fair? Is that the case or no? Okay. And could she slack off and not care and go through the motions and still get the same paycheck? Absolutely right. That's one of the things about this job that's very interesting. You can tell a lot about a person's like moral character, because let's be honest, I could sit here and be like, we're going to do a flipped classroom. You're going to watch random people's videos that I don't know. They might do it differently than I do, and you're going to do a worksheet. I'm going to sit at my desk and read USA Today, You can come up and answer questions, but I'll probably be really short with you. Also, we'll probably show a lot of videos. I really don't care how you do, as long as you're not bothering me, and I'll stamp 100 on it, and we'll call it whatever. Raise your hand if you have classes or have had experiences like that in this building. It disgusts me. You don't get how good you have it here, period. You can go talk to her. I mean, and if you see her, you tell her congratulations. Because that's a BFD to have something like that happen. I mean, you guys don't get it. And they went through and thanked Ms. Coit as well. Said specifically, she made this guy who does, I'm assuming nanotechnology has something to do with that. Ish. Maybe someday I'll sit down and have time to watch what he says. But that guy went to trading. And if you think you all have limits on what you got, you don't realize. You could go and do literally anything. Your high school experience does not correlate into what you're going to be in the future at all. Some of the most popular people, I loved running into them. Let's say there was a girl named Marnie. She was so cool when she was in high school, and she was such a, to say it mildly, mean person, and specifically to other girls. And it was very interesting because you'll realize this too. When you get out of high school, there's a lot of, and I don't want to make a generalization or make anyone feel uncomfortable or be sexist or in any way. There's a lot of girls who, you come in high school, you get attached with baggage. There are people, even like that girl who's from Thomas, that's like this Victoria's Secret model girl. I don't think, from talking with others, she was not Miss Popular in high school. Now she's hanging out with that Hadid girl whose mother was on Housewives of Beverly Hills. Was she popular or no?
Yeah.
Oh, she was? Okay, sorry. Oh, she was bullied? Oh, she wasn't? Well, whatever. I'll tell you this. I remember one of the girls that I went to school with, this girl, Jamie. She was literally, and this girl, I know because this girl, Marnie, was mean to her. Jamie, we're going to say her name was Marnie. Jamie went to do, she just started designing jewelry. And she was walking to some place for, it was like this Claiborne or something like that, whatever. She was trying to get a watch or something, she made something amazing. She was talking at this. She walked in, and they go, the guy looked at her on the elevator. She didn't even know who this guy was. Walked in, and she goes, oh my, the guy goes, what are you in the building for? And she goes, I'm trying to sell this jewelry, and the guy sits there, and he goes, what, jewelry? She's like, yeah, I've got an appointment at this. He goes, whatever it is, I'll walk them down first and stop this. Have you ever had, so, he said, have you ever had a facial, like on your face? And she goes, no. What? And now she's getting creeped out. The guy goes, I'm sorry. He's like, I didn't introduce myself. My name is Ralph Lauren. I want you to be in our modeling campaign. You just need a little work on your skin. We need you though. I'm going to call it whatever this point is. I need to get you photographed now because you are going to be walking in your Fashion Week in 2 weeks. And he's like, have you ever walked a runway before? She's like, is it like walking? He's like, no. So in any case, the part that was so, and you know what Marnie's doing right now? She works at Contillo still. 20 years later, and I love looking, because Marnie, let's say Marnie had some rough years and did maybe some not legal things in high school. And Marnie right now looks like her skin is made out of shoe leather, which is a wonderful look. And Jamie modeled for like 6 or 7 years, made enough money that she could stop. She still sells jewelry, but by and large, Jamie is set for money for the rest of her life. She has 3 kids now. She's beautiful, just a nice person. No one saw that in high school. No one. So stop acting like, high school is life. You can go out and become anything. This guy, no offense, maybe he wasn't the most popular, whatever. Does he probably have a lot of money? Yeah, if he has to do a TED Talk, maybe. So focus on your academics and be the best that you can be. Now, and if you see Miss Ham, what are you going to say to her?
Congratulations.
Thank you for inspiring. Tell her I wanted to thank me for being lucky enough to be in your presence. That's what you say to her. Same thing to Miss Coy. That's what you say to her. Yeah, I mean, she's the real deal. You don't get it. Yeah, nationally, these people are known. Miss Julian, who here has had Miss Julian? Like, certified genius. She gave a speech this weekend at New York State Master Teacher College about stuff that, like, about just how to make class. And who's had Miss Julian? Is her class interesting? I talked to a boy, Brendan McBride and McHugh, the middle one. Rory. I was talking to him, I'm like, what do you want to do with yourself when you grow up? And they go, oh, I want to go into chemistry because of Miss Julie. I can't imagine being so good at your job that you impact someone's whole life, being like, this person made this come alive to me and I want to do it. Like, and these are the people that you work with in this building. And that, again, who's had Miss Julian? Now contrast that class to the one where the person puts the videos on every day and they sit at their desk and they read USA Today, blah, blah, blah. They make about the same money.
That's terrible.
No one says, you got to say, that's why when you get somebody good like that, you got to say thank you to them. Because I'm telling you right now, they bust their butt every day. I talked with her before about what she preps for one class. For one. I feel lucky to be in the same. I hope someday some of her intellect like drips off of her as she's walking down the hallway just to a room, and I can get like one atom of her excellence and absorb that and make myself better. Now, hopefully we'll get through this notes for today quickly. We might touch on this later. I try to overplan for us sometimes. Now, oh yeah, we're gonna watch the pet talk. There you go. Right. Oh, you seriously? For any academic reason? What? Right. So, what we're now, here's, guys, we left off at or around page 5, is that correct? What page is it on? It's on 12 in your notes, is that right? Make sure, please, you go in and check off day 12 on the front. Make sure you go in and check off that we are finishing day 12 on the front. Oh, sorry, day 5. Day 5, page 12, sorry. Calm down. Calm yourself. Whoa! Thank you. Now, what we're going through and working on today has to deal with integrals, the order that integrals happen, and how to evaluate out different integrals. The first thing that you have to see is the order of the integration matters. Notice, if here's my original, it starts, what it says is the integral from a to b of f of x. That's the first thing that's on your paper. What's that? Good. Now, if that's what you're asked and that's what you're tasked with, the next thing we go through and say is, if that's what your task is, what's another way of giving that? Well, what happens if you change the order of your constraints? You would go through and get the area going in the other direction, but to make it the same, it's the negation. The big thing you need to understand is, if you change the order of the constraints, meaning the lower bound becomes the upper and vice versa, you need to negate the integral. Put a negative in front on that integral. Questions on that? Now, here's the other one that we went through and stated before. How many friends do you have if that's the number of friends you got?
0.
0, because you're creating a rectangle with no width. It's from A to A of whatever the function value is. That's not a rectangle, that's a line. Next one up, if you have some constant where k is a constant that's multiplied by the function, the way that you're going to go through and get what that integral's value is to go through and pull out that k and then multiply it out. So what you've got is something that would look like this. K times the integral. If there's a multiplier in front, like a 2 times f of x or something like that, you can go through and rewrite it with that as a multiplier out front. It's just a scalar, so you're going to take the area and multiply it, in this case, by 5. So if I had the area from 3 to 1 of 5 times f of x, that's the same as 5 times the area or the integral from 3 to 1 of f of x. Make sure you write them down. It's not a watch and see. Make sure pencil meets paper. Now, if there's a sum and difference, all that means is of two different functions, all we're saying is you can go through and write it out as two separate integrals. The integral from a to b of f of x, from a to b of f of x plus or minus the integral from a to b of the g of x, plus or minus whatever it's telling you to do. So you can separate an integral out if there's addition or subtraction, and if there's a multiplier in front, you can put that multiplier out front. Take a look at the next one for number 5. Questions on these first 4. And what does the integral represent? Let's go back and ask that. Who remembers what the integral represents? The integral from a to b of f of x. What is that telling us? Or what is that, when you type it in, you get a number. What does that number mean? We got 2 people who can tell me that's not a good sign for us. What is the integral when it's equal to 5? What does that mean? We got 2 people who can tell me, really? Thomas, what does it mean? What does the integral do? Adam, what does the integral do? The antiderivative of the function, sure. Who can tell me what the integral from a to b is representative of when it gives you a value? Captain? Be more specific. Yeah, it's the area under the curve, between the curve and the x-axis. You need to know that. That's not optional. So if you need to write that down again, the integral collects the area under the curve. If you need to write that down again, the integral collects the area under the curve. Take a look at this here. If I take the area from a to b of f of x plus the integral from b to c of f of x, what can we do to that? Who can tell me what they think that's going to be? Sierra? To what? Of the f of x. Yeah, because that b is in common. You're taking the area from a to b and then b to c. Well, that's the same as the area from a to c underneath your curve. And by the way, that means you can split any integral up into 2 smaller ones. Like if I wanted to, I could go through and say, all right, here's the integral, let's say from 1 to 5 of f of x. Who can tell me a way, f of x dx, sorry. Who can tell me a way that I could break this up into 2 smaller integrals? What's one way? There's more than one. What's one way I could break this up? Leah, what do you say?
1, 2, 3 of x dx plus integral from 3 to 5 of x dx.
Who's got another way to break that up? Hands up, please, if you can tell me. Two to 5. Do you have to split it right in the middle? No. Take a look now. Suppose we have these known integrals. So the function area from -1 to 1 under the curve is equal to 5. The integral under the curve from 1 to 4 of f of x is equal to -2. What does that mean, by the way, if it equals -2? What does that represent? David? Yeah, but why would the area be -2? Okay? Yeah, this just means that there's more of it under. There's more under the x-axis than below it. And we know that if we go from -1 to 1 of h of x, it works out to be 7. So notice, the first 2 deal with the same function, the third one doesn't. Questions on those? Now let's go through and start answering some questions. Who can tell me what the answer to A is going to be? Who can tell me, please, what our answer to A is going to be? So far, I've got 1 person, 2, 3. Jack, what do you think? Kanji, what do you think? Careful. Why would it be 2? Who can tell me why this one would be 2? Sierra? Yeah, if you're changing, this one isn't one that we know. What's the one that we know? 1 to 4. So if we change these around, we have to go through and negate. Uh-oh. It's the negative of -2. Because when you change the order, you have to negate what the value that you would get. Questions on that? Take a look at the next one. What would we do to find an answer in B? Hands up, please, when you can tell me what we would do for an answer in B. I got 1, 2, 3, 4, 5 of us, 6. Not bad. John, what do you say?
Add the integral of -1 to 1 of f of x dx with 1 to 4 f of x dx.
And what do you get then, please?
3.
Make sure you have that down, because he broke it down perfectly. He said, well, I know that that total area can be represented by 2 known integrals. That's the area under the curve. I know the area under the curve from -1 to 1 is how much, John?
5.
5. And then the area under the curve from 1 to 4 is how much?
-2.
And that's how we got the total of 3. Questions on that? Make sure the breakdown is there, because I don't want you looking at it and going, wait a minute, where did this come from? Now, this one I hope is very interesting to you, but very doable. Take a look at C. We'll wait for 6 of you that can tell me how we get an answer in C. I've got 1, 2, 3, 4, 5. You get 5 right away. That's great. That's great. Megan, what would you try? And get? Yeah. All I did, the only thing I'd ask is you just show me this intermediate step here where you're pulling that out. Okay? Your numbers and everything are right, and you clearly articulated that you understand the concept. Raise your hand if that made sense to you. Okay. Let's look at the next one. What would we say for D? Hands up, please, when you can tell me. Did I make a mistake? What?
Well, if I know the first alphabet, not the second one.
You can tell me how they know it's the first f of x and not the second one. Look at the constraints. Who's got an answer for D? We got 1, 2 of you. 3, 4. Everyone in this row must be, if you're really close to me, you'll really get it. I should start standing over here and yelling louder. You can tell me what answer you'd say for D. Josh, what do you think? What? Casey? He's on the right track. He actually said something good today. Not 0. Look. Nope. Can't be determined. We can't assume. Now, somebody was saying, if I know from -1 to 1 is 5, can I just take half of it? Can you do that? No. It's some function. Is it linear? Is the area equally split? What is it? Who knows? What about for E? What are we going to say for E? 2, 3 of you, 4. Come on. Anna, 2, what do you want to say? Close. You went through and you're trying to make this connect to this, right? Can I make this connect to that? Think about it. You're starting 1 unit before this and 1 unit after. You should be struggling with it. You should be. That's the whole point. It can't be determined. Because do you know what's happening? No, you're right. You're sitting here doubting yourself. You're right to try to link it to it. And that's the mistake that people make, is saying, well, I know what happens from -1 to 1. So the function could literally look like this. If this is this h of x, and what was it, -1 to 1, is that right? All right, then let me do this. Right? This is h of x, and what does h of x come out to be? Is it 7?
Yeah.
So we know that from here to here, something happens such that this area here ends up being 7. By the way, are we assuming, I'm making a big assumption here. Do we know that it's all above the x-axis? No. You just know the overall net area from here to here is that. Do you know anything about what's happening here? This, by the way, would be -1, -2, 1, and 2. Do you know anything about what's happening in those two regions? Anything? No. Can you make the adjustment then? Is there some manipulation to do? Absolutely not. When you're doing it, it's good to sit there and say, wait a minute, this isn't making sense because I don't know what's happening. Which is why when Jason said, when you said, that's good, you're supposed to say this isn't making sense. And it's because it can't be determined. Now the last one does have an answer. The last one does have an answer, so go through and figure it out right now. And show me why it is what it is. Go through and figure that last one out right now. Yes, it does have an actual answer. What did you say? You can't do all of it. What do you want to say, Evan? Now, I did this right here, because he got 3, right? And how did you get the 3? Where did that come from? And was that one we established before? Yeah, that's part B. What's the problem, though? We also have this, right? What's the value of that integral? We don't know. So what do you think the overall answer is?
3 plus rho plus -1.
How about 3 plus cannot be determined? What's that going to be? Yeah, it can't be determined. Questions on that? What's that? And then I said, or does it? Because if I said it didn't have an answer, everyone puts their pencil down right away. You got to learn the game. Now, let's go over here. This is the only other part, but this is so huge. There's so many questions that get asked about this. It's the average value of a function. The average value of a function is the slope of a secant of the antiderivative. Meaning, you've got to go through, the secant connects the start point and the end point. So you've got to go through and figure out what that's going to be. Now, here's the formula for the average value of a function. Make sure it's down. It's 1 over the distance if you need it. You got to know, I'll put it to you mildly. This is going to come up constantly. These are questions that even I go through at times and I'm going, wait, which one is this? Because we talk about average value a lot, and it comes up huge on word problems. Average value comes from taking 1 over the distance covered times whatever that integral itself is going to be from B to A. That gives you the average value of the function. Now, next one up, it says go through and find the average value of that function on that interval. So that's A and B. Does F actually take on this value at some point during the interval? Now, let's first go through and figure out what the average value of the function is going to be. What do I have to write out to figure out what the average value of this function would be? Abby, what do you think? What would I have to write out to figure out what the average value of this function is going to be?
The average rate times the integral
There you go. That's what needs to be down on your paper. The average value of the function is equal to 1 over, technically you could simplify it down, it's going to be 1 over what? 1 over 2. Now, here's what we need to go through and compute. This right here is not linear. What shape is this function going to be? Parabola. We don't know how to take that by hand yet. So what we're going to do is you're going to go through and plug that into your calculators. So go through right now. You tell me, plug it right into your calculators. Take not the whole thing. I just need the value of this right here. I need you to just to compute the value of this right now, and you can use your calculator to do so. and let me know what value that comes out to be. Hands up, please, when you can tell me what's the value of that integral going to be. We got one person, 2, 3, 4. Sierra, let us know what you get, please, when you get it. Do you know what that comes out to be as a fraction? Does it give you to you as a fraction or no? -4/3. So, and by the way, what is the first fraction, Davey? What is 1 over 1 minus -1? What's the same? That's the same as. So 1/2 times -4/3 is going to leave you -4 over 6, which is -2/3. Now, the question is, does the function take on the value at some point in that interval? How can you answer that part? Does the function take on that value at some point during the interval? How could you find out? How can we figure out? Yeah. Set the function equal to -2/3. So go into your calculators right now. Let's solve this out. This should be very, very quick. What do you do to get an answer in this? Hands up, please, if you can tell me. What would your first step be? Seriously? What would your first step be, Mike? You could. We could make it easy if we're not afraid of fractions. Steve? Add 1 to both sides. What's -2/3 plus 1? 1/3. What do you do next? And what do you get? Now, is the AP going to make you rationalize that? Am I? I'm too nice. Yes, the function has the value of -2/3 at that. Notice, it's the function value is the output, or the y equals. Questions on that? This is a repeat of a question you had before. A particle moves along a line such that the velocity at any time is greater than 0 is given by that function where f is measured in seconds, c is measured. Find the average velocity during the first 3 seconds. What would I do to find the average velocity of this function during the first 3 seconds? What would this look like? We got to pick up the pace here. What's this going to look like? What's the average velocity?
3 minus 3, 1 over 3 minus 1.
Nope. That's one way of finding it. Here's another way of finding it, using the average velocity. That's one way. We're talking about using the average function value, because you know what velocity would be.
1 minus 3 over 0, or 1 over 3 minus 0, integral 0 to 3,
Mm-hmm.
x.
Yeah. And could you type this all in the calculator at once? Yeah. You wouldn't be asked to, because this one, taking the antiderivative of this is kind of easy. But it's the change in the y over the change in the x. Now, what I'm going to ask you to do tonight is this. See this question? Get this question down here done for homework. You can use the calculator to help you. You would actually need to use the calculator to help you. Get that done, in addition to whatever is on the chart for today. Hang on. I think I know what you did wrong, but I'm not sure. Yeah, you know what you did wrong? You did x squared plus 1. See how now we're okay? It's a 2-day test here. Good. I'm going to not forget to lose your phone. Here, you got it. See you later, guys. Have a great day. Change the world. Tell Miss Hammond, Miss Boyd, thank you.
You learn a whole new thing.
Usually,